Hello, I'm Jennifer McClendon, Education Manager for Sportsfield Management Association. Welcome to our post-conference education series. Today, our speaker will be Brad Jakubowski. Brad has been in the green industry for over 30 years and has been active with SFMA for over 20 years. He currently teaches for Penn State University and enjoys working with sportsfield managers at all levels. He is excited to see how much the association has grown and treasures the opportunities to see it continue. Today, Brad will be presenting Take the Million Gallon Challenge. Brad?
Great. Thank you, Jennifer. Thank you for all for being here this afternoon. It's a pleasure being here. I've always enjoyed doing presentations with the sports field managers. They're a great group, and I've loved them ever since I started. So Tony Koski out at Colorado State actually was the one that actually encouraged me to come out here first off. So I owe me being here to Tony out there. So he's kind of an old mentor for me. So today we're going to talk about taking the Million Gallon Challenge. And this talk came about from years ago. I was working with a gentleman out in Nebraska, and we were actually doing the Take the 1,000 Gallon Challenge for homeowners. And we said, you know what? We really need to kind of work with the sports field managers and see what we can do with this one. So this is kind of the direction that we went with this one. So let's go ahead and let's see what we can do as far as saving. And essentially what we're going to try to do then is save 1 million gallons throughout a growing season. And that's kind of where this Million Gallon Challenge is. And so let's press on. So first question is, gosh, how much is a million gallons? Well, if anything, we could fill with 1 million gallons, we could fill a 50-gallon bathtub 20,000 times, or this water tower, we could fill that once. That they normally carry about 1 million gallons. And if we're working in the city, many of us athletic field managers may actually be using municipal water. And so this may be one of our primary water sources, actually. Other things, we could fill a 200-gallon sprayer 5,000 times with 1 million gallons. So if we had one of those water towers in our backyard over at the shop, we could then have plenty of water to fill plenty of tanks over the course of a season or the course of our lifetime, actually. So those are some of the other things. So that's how much a million gallons is. Our challenge today is then to kind of figure out what can we do to conserve 1 million gallons or more throughout the course of one of our seasons. And this was kind of what our challenge was. And I thought this was kind of interesting. It's been kind of fun to kind of work with this one. And is it even possible to save 1 million gallons? Okay, well, we can save it through sprinkler choices, the different kinds, maybe going from some less efficient sprinklers to more efficient sprinklers might be one way to do that. Maybe it's a little bit some changes in design or improvements in the design of our systems. Okay, capacity, maybe it's a pumping system versus a different kind of water source system might be something that we may be looking at. Could even be just drinking fountains. If all of you have drinking fountains at your facility and you see them seeping or weeping and they just don't seem to want to shut off, how much water are they actually, how much water is running through them through the course of a growing season or one of our game seasons? Could be that, or even what's going on in the bathrooms. Do we have a leaky toilet or a urinal that's kind of just keeps wanting to run a little bit and doesn't want to shut off very well? And how do those impact us as far as overall water use? And so those are some of the things that we're going to kind of take a look at today. Okay, so next question. Why save 1 million gallons? Why would we want to do that? For you guys that are out there, what would be some of the good, anybody have an idea of why would we want to save 1 million gallons? How does that benefit us as a turfgrass manager? Would anybody care to answer that one or just kind of give a suggestion of why? That one, anybody? Money, you bet. Money is a big one. So that'd be a big one. So money is very important. Absolutely. Any others? You think? And actually, money is number one on my list. And so let's take the list that I've got here. And so money, absolutely. Next one might be public relations, PR, maybe something else that we can do with that one there. I don't know, have any of you been approached by somebody where, sometimes you drive by a bank and all of a sudden it's raining and you see the sprinklers running while they're driving by there or something like that, or down a median and the sprinklers are still running. And so, or somebody may come up to you and ask you, gosh, you're running those athletic fields, is it really necessary to use all those resources and water and things like that? Oftentimes they'll approach me about that. Why are you in this particular business? And so public relations can be another one. Stewardship, just being good stewardships of the limited amount of water that we oftentimes may have. Or another one might even just be integrated pest management, or what I like to call integrated turf grass management. How do we manage our water to be able to better manage our playing field, the skinned area, diseases, weeds, all those kinds of different things. So there's a whole bunch of different reasons why we might want to save 1 million gallons. Okay. Another one here. So I just wanted to introduce you to TJ Brewer. If you've never met TJ, he's the turf grass manager out at the Cincinnati Bengals. And I kind of sometimes he was one of the first people I'd given this presentation to a number of years ago when he was working a minor league field back in Iowa. And it was interesting. He really kind of thought this was interesting. And so he went out the next couple of years, and his goal was to save 1 million gallons. And then he was able to do that. And so then he actually was then able to give some talks on how he saved that 1 million gallons. I oftentimes give him the hard time because he went from a natural grass field to taking care of a synthetic field. And I said, it must be pretty easy to save 1 million gallons if you're doing it that way. But now that he's at the Bengals, he still has his practice facilities that he still needs to do. And he's still kind of in that same frame of mind as what can I do to save 1 million gallons through a season? Okay, so let's move on. Again, why save 1 million gallons? Well, one of the things we talked about was money. And the average cost these days, I don't know if you guys are running off of well or municipal water or whatever it might be. Right now, average costs for municipal water is anywhere between $4 and $8 per 1,000 gallons. And this container over here that I've got over here on the right, this is a 1,000 gallon tank. And so for each one of these 1,000 gallon tanks, it's going to cost us, let's say on average, about $6. Which if you think about it, that's actually a pretty decent deal, because if we go somewhere else, it might cost us $20 for a case of these, or $7 or anywhere, $7 to $10 for a 5-gallon tank here. So, comparatively speaking, sometimes it can be better, but this is kind of what we're looking at. So, so in this case here, let's go with $6 per 1,000 gallons. And we need to figure out, okay, how many 1,000 gallon units are there in 1 million? Well, there are 1,000 1,000-gallon units in 1 million gallons. And so if we were to take $6 times 1,000 of those units, we could actually save $6,000 in a growing season just by finding a way to save 1 million gallons. And so those are some of the things that we would kind of try to look for. What are some of the little things that we can do? Can we save 10,000 here, 20,000 there, another here? All of a sudden, those gallons start to add up really, really quickly, which is kind of nice. Okay. And so again, all of a sudden, that $6 turns into multiple $6 as the season goes on. Okay. All right. So again, why save 1 million gallons? We've got public relations. Is that one of the things that we might be looking at? Can we actually have something posted in the news or online or something like that? We saved 1 million gallons. And, all of a sudden, some of the people that might be a little bit concerned about water use and the things that we're doing for athletic fields and golf courses and parks, why are they wasting that water? Well, if we can save 1 million gallons, all of a sudden that might make a difference. Or over something like this, if you've got a Facebook page or an Instagram page or whatever it might be, could you actually then post this? You know what? Last year, this year we actually saved 1 million gallons. Thank you everybody. Let's try for 2 million gallons. All of a sudden, you can do something like this and really celebrate your efficiency, or improves in efficiency to be able to make this happen. So this is another thing that you could even do. Okay. Or like this was another thing that the city of Bloomington did, and they were able to go out there and kind of then, once they saved 1 million gallons, then they were actually able to continue to then post, we are up to, 7 million gallons. It's kind of like some of those manufacturing plants that, when they do it, they'll say, so many days without an accident or something like that. So it's also something you can kind of celebrate. It's like, what, we're up to 1.5 million or 2 million gallons. And, people out there, they're going to say, wow, that's pretty significant. So again, stewardship, just if we're limited on water and our resources, just being able to save 1 million gallons just might be helpful that way. Or again, trying to limit diseases and or weeds. Are we struggling with having too much poatriv in our outfield? Well, being able to cut back on irrigation a little bit, maybe that might stress it just a little bit so that we can replace it with perennial rye or Kentucky blue or tall fescue or whatever we might be using. Or if we're down south, some kind of, Bermuda grass or something like that. So there's some different things that we can do with saving 1 million gallons. Okay. Or out there at Petco Park or out there in San Diego, this is one of the things that they would also then let people know as far as PR goes. To conserve water, the playing field is watered on a timing system with moisture monitors that will adjust watering as needed. That's a great way to just let them know that, we're just not just dumping a whole bunch of water out there and fertilizer and all kinds of things to get these things to look so good. It really helps us to show them that, what, we're pretty darn good at what we do. And this is one way to show them that, on limited resources, which we all have, are limited, that we can actually make a pretty darn good looking field with minimal resources and materials. Okay. So again, why save 1 million gallons? Water efficiency is important. Now, this is kind of good to remember. It's important no matter the reason that we do it, or the source, or the method of use of how we do it. All of these things then become very, very important. It's, in a sense, it's just very critical that if we can do this, it makes a difference. So they provide, by saving 1 million gallons, it provides tangible evidence of, one, documenting that your facility is a wise water user. So all of a sudden, record keeping, monitoring your meter or whatever it is, how much daily flow that you're using, can be very, very critical in this case here. So then just documenting that your facility is a wise water user. It helps you to defend yourself whenever those questions might come up. Another one then is just promoting environmental stewardship. And there may actually be different grants or different prizes or things that you can actually then apply for that may actually help with this in this kind of a situation. Another one then, finally, this one here, I like this one the best, is it also provides tangible evidence of you being a proficient turf grass manager. And in this industry, we have to be. For us to keep our job or just to, keep the business running, we have to be as proficient as possible. And if we can do this, and by just recognizing the little things, it can make a huge difference. Okay, so how do we save 1 million gallons? Well, one of the things that would be very important then is, first of all, identifying overall water usage of an entire facility over a course of a year. And, that might come from final, overall water bills, yearly water bills, and just water usage, just, again, record keeping. From there, then implementing, for how else do we save it? Implementing various outdoor and indoor water saving practices. It's not just what we only put down on the field or on the skins or wherever we are, but it's just a matter of indoor, outdoor. If we can then, record anything that we see that's dealing with water, we can do it. So does it really matter how you save it? Not really. So record keeping then all of a sudden becomes key when we're doing this. Okay. So I was speaking with John Scott out there he's vice president of agronomic services with Nicholas. And this is some of the things that he tries to keep in mind when he's dealing in this or when he's doing designs is water saving starts in the mind, and you have to really be committed to it. And once you start doing it, it becomes pretty straightforward for us. So let's start saving 1 million gallons. How can we do this? Okay. So one of the biggest things out there is just improving our irrigation scheduling. And this would be something that you can kind of ask yourselves is, while we were out there and we kind of put out a notes out there and finding out from other people is, how do you then schedule your irrigation? And what we came out to be is that 97% of them use some kind of observing the turf. Like where we would always talk about, are we starting to wilt? Do we have footprints going across there when we do that? Do we see some stress areas? And so 97, most of us then use observations of turf. Some of them then use soil moisture observations or short-term weather forecasts. ET rates from the Weather Service, just matching ET. Well, you know what? My plants took up an inch this week. Well, then I need to put down an inch this week. And then all of a sudden that answers the question is, how much water does my system put out in a given amount of time? Okay, one of those things. Also then long-term weather information, soil sensors, and some of them just kind of guess and go from there. So there's just some different things that we can kind of look at. So let's take a look at a few of these things that we can do to improve our irrigation scheduling. So soil sensors. Some of you might use some of these, or just soil or moisture sensors. Some of you might have used some of these in-ground ones like this, or atmometers. These atmometers will then also can give you good ET information by just kind of simulating what's over on this part here is what evaporates off the soil in addition to what evaporates into the atmosphere. These atmometers can then help you to find out what's going on with soil and air kind of dynamics with some of those things. So one of the things there. Have any of you ever used a TDR or these probes like this to kind of monitor soil moisture in the soils as you're going throughout the week? Golf course superintendents, oftentimes they'll use these on their greens when the greens get down to, let's say, 13% water moisture per volume. Then with this, then they'll say, you know what, 13%, this is when we need to start irrigating. We can then do the same thing then on our baseball fields is, find out when is that stress time? When do we really start to see those footprints out in right field or left field or somewhere out there? When do those things really start to wilt? And you can actually then take some moisture sensors and go out there and take some samplings and say, you know what, well, these things start to stress when it gets to 18% or 12% or whatever it is. And that might be a nice cue to say, you know what, we can actually push our grasses just a little bit and save a little water doing it that way by using one of these TDR probes. Okay. Again, soil sensors, and they're becoming much more easily readily available for us. And so there's a whole bunch of different kinds of soil sensors, as you can kind of see here. Some that you can kind of punch into the ground here or bury, or some of the old-fashioned ones like here, or even like this one here. I pulled this one off the internet recently. And installing a WaterSense labeled soil moisture sensor could save an average home with an automatic irrigation system more than 15,000 gallons of water every year. And so I got to kind of thinking about this one. It's like, okay, 15,000 gallons. What would it take to actually save 15,000 gallons? And so then I was thinking about this, and it's like, well, let's say if we had 80 irrigation days throughout the summer, and that would then equate to about 180 gallons of water per day. Not bad. That's pretty easy, and we can get that. Or what that would be, then it's actually like a 70 or 80-second reduction in runtime for a 10-station I-25 system, in a sense like this. So if you had 10 stations and they were all running I-25s, and all you did was cut back, let's say 2 minutes, or actually less than 2 minutes per run for each of those stations throughout the season, you could then very easily save, in this case here, 15,000 gallons, which I thought was kind of interesting. And so oftentimes it may not take much, but it might just be a matter of then just taking a small change and seeing what happens, or even kind of pushing your turf. Well, you know what? I usually have my sprinklers at night. They're usually running at about 15 to 18 minutes. Well, what happens if I cut back 10% or, a couple of minutes? What difference will that make in our fields? Are there some differences, or certain zones? Can we run some of these zones at different times as well? So it can also make a difference. Technology. I don't know, have any of you had a chance to use drone technology monitoring soil moisture or temperature, leaf color? Oftentimes we can then get stressy situations like this where you can kind of see what the infrared signatures are, and where you can kind of see where these sprinklers just weren't quite doing very well or something like that. Or like on a baseball field, you may even just take a photo and find out something like this. So from your experiences, if you saw something like this with a bunch of crop circles out there, what does this tell us about our irrigation system? Any of you, if you've ever experienced this, how does this impact us? And with this one, when you start seeing donuts like this, or you see a bunch of crop circles like this is normally an indicator that you have low water pressure. And so then it's a matter of finding out, well, do I have leaks? Are 2 stations running at the same time? Is one not shutting off? All of those kinds of things. So there's a number of different things that you can kind of start to monitor, where they've definitely got some serious crop circles going on here, and maybe they have some heads that just aren't working at all, where these are just kind of a little bit more on lower pressure or something like that. So this would be something else to be able to use, is really utilizing just simple drone technology, or just standard photographs. Another one here would be monitoring short-term weather information. So I've got a question for you. So we've got these two here. We've got on Monday, June 11th, today's high is going to be 96 degrees with 15-mile-an-hour winds out of the south. Or on Friday, June 15th, today's high is going to be 93 with 6-mile-an-hour winds out of the southwest. And so then, off the top, I would normally then ask, attendees on this one here, which day would have a greater need for irrigation? And just by this limited information, you'd probably think, well, Monday definitely going to have a greater need for irrigation. Well, if we take a closer look at this one, is what we're seeing here is this is an hourly weather graph of these 2 different days. And what we're seeing here is here is that 96-degree high temperatures here, right? On Monday with those winds out of the south. And then over here, we got those 93-degree temps here. But what we're not seeing, or what they didn't tell us in the forecast, is right along here, what this is showing us is that we have a dew point of 72 degrees. And a dew point of 72 degrees, that's extremely humid. So in this situation here, we're having hot temperatures and extremely humid conditions. And so on days like this, it may be hot, but there is so much moisture in the atmosphere already that chances are you really don't need to irrigate on a day like this. Or if anything, maybe run a syringe cycle, and that'd be about it. Where over here we have a 93-degree temperature, high temp, with dew points in the in the teens, 20s in the teens. This is hot with extremely dry conditions. And so this one, our plants are going to be blowing through water like nothing. And so this one here definitely will need irrigation, where this one, even though we have higher temps at 96, chances are really don't need irrigated, but this one really would. And so, again, what we're tracking is temperatures and dew points. And so right here, low dew points like this means it's very, very dry. This one, we have high dew points, meaning it's very humid. And so big difference there between the 2 days. Okay, so this one doesn't really need irrigation. This one probably definitely would, or definitely some serious monitoring if we have a day like this. Okay. All right, another one. I don't know if any of you have actually conducted an irrigation audit or had gone through one of these. Oftentimes, most people think of, like down over here, is when we're looking at this, is putting out the catch cans and seeing how well the water is being distributed. There, that is one way. That's one part of an irrigation audit. Okay, and that's one of the things that we would normally do, is just to see how well is our irrigation sprinklers, how well are they doing. And so with this, an irrigation audit, it does measure distribution uniformity, but it also does a lot more. And the question is then, when you're running an audit like this, is how long do you have to run your system to adequately irrigate the driest 25%? And so that's what you're always trying to do, is you're finding the driest areas in your fields, and you have to keep those alive. And then, by doing that, that means a lot of the other parts of your fields may actually get too much water. And so this is where trying to make sure that your sprinkler systems and your irrigation systems are actually then running at peak performance or peak efficiency. It's important then to make sure that there's not a big difference between the dry areas and the wet areas. That's kind of what this comes down to, is you want to try to not have really, really dry areas and really wet. You want to try to find somewhere to bring those into the middle. Okay. So from there, excellent is 80%. If you have an 80% efficient system, that's an amazing system. It's very, very good. We start getting down to 50%, that's our one that really, really struggles. And so normally athletic fields, we normally average between 60 and 70%. So we're kind of in between. We have around the good area here. So, excuse me. And so large properties might be at 60%, possibly. Homeowners associations, maybe around in the 50s. And then parks also kind of around the 50s as well. And so just because it's just the nature of how they're installed and the kind of systems that they have with it. Okay, so just as an idea of how one of these things run, if you wanted to find out what your distribution uniformity is, it's just a matter of you would essentially take the low quarter divided by the overall average of everything else, of the others, and find out, well, you know what, our overall average, let's say for this particular system, is 50%. It runs at about 50% efficiency. Okay, and so from here you would then say, okay, what does that mean for me? Okay, so let's say we got these places are receiving a half an inch, where this one's only receiving a quarter of an inch, which makes a huge difference. Okay, all right, so what does that 50% mean to us? Okay, well, we ran our numbers over here and we wanted to find out what's happening once we did all our catch cans. Okay, so let's say with this over here, we're using I-25s, or these particular sprinklers, and with these nozzles, and they're putting out about 5 gallons a minute. And we're going to say, let's say they put out about a half an inch of water per hour. And that's kind of, we're going to, instead of 0.55, we're going to simplify it and just make it, let's say they put out a half an inch of water per hour. Okay, so what that means then is that if our goal, let's say the grass required a half an inch of water and the system was running perfectly, then if our goal was a half inch and our precip rate was a half inch per hour, and the system was at 100% efficiency, we would only need to run the sprinklers for 1 hour. That's how this works. That's kind of what this is showing us here, that if we ran these sprinklers for an hour, we would get about a half an inch of water from them. Okay. So, however, what we're doing here, if our system, let's say we only have a 50% distribution uniformity, that means that we would have to run our sprinklers for 2 hours. And what that means then is how you would figure that one out. Let's say if we did our system and our DU was a 0.5 or 50% efficient, you would take, well, it would require at a perfect system, we would need to run it for an hour, but because we're only 50% efficient, we would take 1 hour divided by 50%, and it would come out to 2 hours. So then to make sure that all of this part here gets the same amount or gets enough water to survive, we're ending up overwatering this twice, where this one would finally get what it needed to be there at a minimum. So that's why it's important then to have the highs and the lows as close as possible together. Okay. All right. So what does that mean for us then? Let's say at this point, this particular situation here, if we're running these sprinklers at 5 gallons a minute and we have to run them for 2 hours or 120 minutes, that's 600 gallons times 40 sprinklers, which would mean that we're looking at 24,000 gallons per irrigation event. So every time you run those sprinklers on a particular field, it would take 24,000 gallons. And then we could kind of start doing the math that way as well. Okay. So let's say instead, so we kind of keep this in mind, we're looking at 24,000 gallons it's going to take to keep all of this grass alive. This is going to be a little bit more wet. This is going to be just sufficient. Okay? So let's say we were able to improve the efficiency of this area here. Instead of a quarter of an inch, we just bump it up to 0.35 inches or a third of an inch. Then all of a sudden that increases our efficiency overall from 50% to 70%. Okay. And so what does that mean for us? Well, let's run the numbers. Okay. And so in this case here, if our goal was a half an inch and our precip was 0.5 inches, so now we're going to take, we would take then that 1 hour divided by 0.7, and we're only going to see that instead of having to run those sprinklers for 2 hours, we would only have to run them for 1 hour and 15 minutes. It's become that much more efficient instead of by just fixing the sprinklers or finding out what our problem was. So instead of a 2 hour runtime, now we're only at an hour and a quarter, which makes a huge difference. So what that means, by running it just for those 85 minutes or so, then what we're looking at here is instead of running 24,000 gallons per irrigation event, now we're only running 16,000 gallons per irrigation event, which means then that we have a 7,000. So every time we run our sprinklers for that amount of time for this particular area here, we're saving 7,000 gallons. And so if we had 24 irrigation events, or 12, if we put down 12 inches for the year, we would save 168,000 gallons. And so a lot of math, but there's some things that you can kind of, just by changing how efficient your sprinklers are, you can make a huge water savings in a very just kind of relatively easy situation in this kind of a situation. So I just want to kind of show you that just by changing our irrigation efficiency from 50% to 70%, all of a sudden we can have a pretty good water savings event. Okay. All right. So it's about 14,000 gallons per inch is what we're saving if we needed to do that. So if we kind of run that, so if we needed more than 12 inches throughout the growing season, if we needed 18 inches, we could then say, you know what, we need another 6 inch, it would be 6 times 14,000 gallons. That's how much we would save throughout the season, kind of thing like that. Okay, so you can use different kinds of things when you're doing an irrigation audit. You can use the official catch cans like these that have got the little gradations in them, so you can read the volumes. Or you can use tuna cans. This is a tuna can right here. And the nice thing about using tuna cans is they have these perpendicular lines where all of the edges are straight up and down. And when you have a can that's got that looks like this, what you can do is you can put a ruler directly in there and directly measure how much water. I ran the sprinklers for 20 minutes. How much water did I get? And you can stick a ruler in there and find out, you know what? When I run the sprinklers for 20 minutes, I get 1/8 of an inch or whatever it is. So whenever you're using cans that are perpendicular, they have these kind of, they don't have like a, kind of slanted edges on them like this. You can take a direct measurement with a ruler, and it makes it really easy to just kind of get an estimate of how much water is going down at a given period of time. Okay. So again, other things that irrigation audits will help is, finding out what's happening with my water supply. Maybe you're able to kind of do some investigations and find out, you know what, we've got some steel pipe out there and it's starting to basically kind of corrode. And instead of it being a 6-inch pipe, right now it's down to a 2 or 3-inch pipe. It can make a huge difference on that. So you're going to check that. You'll check your pumping system or your piping systems and fittings. How's everything doing? Are the valves working okay? Okay. Sprinklers, the control system. Do the sprinklers out in the field, do they really match up with the kind of sprinklers that are supposed to be on how the controller is set? With the particular sprinklers that you have out there right now, let's say it's been set for the last 2 years, it's been running at 20 minutes a station. Okay. And in that 2 years, let's say you went from brand A sprinklers to brand B sprinklers, and all of a sudden, maybe that means that you have a totally different application rate, and you might need to reevaluate how long you run those sprinklers. Maybe I can cut it from 20 minutes to 15 minutes or something like that. Also, do any of you then ever monitor your rotational speeds on the sprinkler heads? Because sprinkler heads then are designed to have one rotation in 3 minutes. The fast ones that they have, we use on skinned areas are they're about half or 2/3 of that. But normally you can kind of time it, and most systems and irrigation or precipitation rates then are based on a sprinkler head having a 3-minute rotation. And so sometimes you might want to just take your phone or your stopwatch out there and actually kind of time it and see how long it takes for let's say a 360 to rotate, and you can kind of find out how well are they doing. And so it's usually about a 3-minute rotation on there. You can also then evaluate what your management practices are, water distribution, again, just by even sticking a screwdriver out in the field after an irrigation event and seeing what are some of the differences in how it feels and how that screwdriver is going in there. It can be something else as well. So you can do that. Also, with a pitot tube, this is what we call a pitot tube. And a pitot tube, what it is you've got this little tube, you put it right into the stream of where the spray is coming out, and it'll actually give you a dynamic pressure rating over here, just kind of a readout of what your pressure is, active pressure is on this. These can be very, very helpful to find out, are my sprinklers really acting, or, basically applying water at the given speed that we thought they were supposed to be, is what you can do with those. Okay. And so that's one of the things that you can do, is you can do these on different heads. And it was actually very helpful when we were running an audit on a particular system. This is what a pitot tube looks like. So you've got your pressure gauge here, and then you put this little piece right there. And so this little piece right there will just go directly in the stream of the water, and then you can actually find out what's happening with dynamic pressure of each sprinkler. And also, or if you wanted to, if you've got some dug up or whatever, you can actually then put a pressure gauge kind of on the riser or off of the swing joint over here, and also test your sprinklers this way if you wanted to. Okay. So what happened one time is I was out there, we were doing an irrigation audit in this particular field, and this is actually in the same zone right here. It's actually on the same lateral. Is that one of the heads tested out at 70 psi. This one tested out at 40 psi. So I went to the turf manager over here, and I said, so why is there such a difference over here? Have you been doing anything with these? And he says, well, actually I did. He says, this sprinkler over here just didn't look right, so I put a bigger nozzle in it, and so it made it look better than this one. And what it did is it actually completely changed the dynamics of how this thing was applying water out there. So all of a sudden, this one was rated at 70 psi, this one was down to 40 psi, and he was really having some struggles out here where he had to really water these areas in here a lot more than he did over on this other side. So we had to kind of do some investigating and find out what could we do to make that happen a little bit better. Okay, so again, can be also very helpful to find out where are your inefficiencies. Do you have problems with piping or nozzles or clogged sprinklers or whatever it might be? This would be one way to kind of find out that way, is using a pitot tube and doing dynamic pressure checks. Okay, and so this is kind of what we showed. So when we actually tested those, this is kind of what we looked at here. Is this was that 70 psi sprinkler, and in a given period of time, it was actually put out about 10 mils of water, where the 46 psi only put out about 4 mils of water over here. And so there was a pretty significant difference as far as how much water this sprinkler was putting out compared to this sprinkler. And so those things can really make a difference. Okay. All right. And so with our goal here, if this is our goal here and we're putting this out, you can kind of see that you would definitely need to run this sprinkler longer to reach that 1-inch goal, where this one, let's say you only have to run this in 20 minutes. This one, you're probably gonna have to run 40 minutes, close to an hour, just to get to that 1-inch goal over here. Huge difference. Okay. So visual inspection can be another thing to kind of keep an eye on, is just, do I have standing water? And also when you're checking this out, does the water stink? Does that area stink? Has it been doing this for a long time, or is it just fairly recent? And so that would be one of the things. Does it have a rotten egg smell, or does it not? Okay, would be another thing to kind of check. Again, from over here, if you're digging up and doing some sprinkler repairs, kind of monitor, take a look at what the soil's doing, what your roots are looking like. Anytime you do these digging, go ahead and take a look at the roots and see how things are going there. Do you have black layer? And this is at one of the baseball fields that we had. It had a pretty significant black layer. And so it also smelled a little bit on the rotten egg side. And so we had some rotten egg smell going on and a black layer. So then again, in addition to just watering, differently, this is where chances are you're going to recommend you really need to do a pretty serious aerification to make sure that you can kind of break through this and help those roots become a little bit more efficient in receiving that water. Okay. So recommendations from the industry, things, really learn to work with what you have, survey your facility for wet and dry spots, try to find different things. This is one of the things I thought was really interesting was mark them on a glass covered as-built in the crew room with a grease pencil. And so we started doing this. It was really kind of interesting. And so what you can do then is, even put together, use an as-built or use your own map and then build. And then as you're doing that, I'll kind of get around it, but you can kind of, if you see donuts or crop circles like this, or something like that, or you see something like this going on, well, maybe there's something I can do, or at least mark it down so you don't forget about it, because it's more than just perception. When this is happening, it's perceived as losing water, but you also are losing water. And so this can be very, very important. Okay, because all of a sudden you got water running everywhere. You can almost find out how much water am I losing each irrigation event. Okay, and so another thing we're going to kind of take a look at then here is what are some of the different types of irrigation system improvements I can make to save water, but not necessarily spend a lot of money. And so this is kind of this was a survey that was put out. And as you can kind of see here, what we have is that these are some of the less disruptive improvements you can make, all the way down to where we've got kind of go down here to the more disruptive ones, which ones take a lot more work, and you're going to take some pretty serious improvements with this one here. So sprinkler heads, that's one of the big ones, the best ones you can do as far as being less disruptive and bigger improvements. New nozzles. So sprinkler heads and nozzles are a couple of big ones. Adding sprinkler heads, new software for controls, new field controllers out there, pumps, master controller, or removing sprinkler heads might even be something that you might need to do, or a pump station, lateral lines, main lines. Now we're getting into some of that stuff that really takes a lot of digging, and it's going to take some time off for us to kind of have problems with that. Could be another one of those things that we have to kind of look at there. Okay. So also drain check valves might be something else that you might want to take a look at with this one here. I'm not sure. You'll have to kind of find out, do your sprinklers have check valves in them? And so oftentimes it's just a little rubber disc that comes in here, or it's also located here on your sprinkler heads. And so what this does, these check valves then, instead of the water running out of the top of the head, let's say if you've got a pretty good slope on your fields, then some of that water is going to naturally just drain out of the heads. These check valves, what they do is they keep the water in the lines and not let the water run back out. So you don't have to refill the pipes, okay, so to speak. And so what this makes a difference. So if you've got some low areas there, if you've got a pretty good crown on your fields, you may not see them kind of pop the water running out like this, but without check valves, and you've got a crown on your field, that water's going to then kind of empty itself out of these pipes that way. Okay. And so for this baseball field, let's say we have 2,000 feet of 1.5-inch pipe, and 50% of that water drains out when the system shuts off because there's no check valves, and it just kind of naturally seeps out of those sprinkler heads. Excuse me. So we're looking at about 5 gallons per 100 feet of pipe, okay, or 100 gallons drains out of there per every irrigation cycle. And so then if you have 128 irrigation days per year, that's about 12,000 to 13,000 gallons that you could probably save by just adding these little rubber discs on the bottoms of your sprinklers. Okay, very, very simple. Okay, if you had 270 irrigation days, if you were watering almost every day, because you're in kind of some of those warmer areas, you could double that, or you may have up to 27,000 gallons that you could save. Or you can kind of see this is how much it'd be, about $77 worth or $167 worth of that $6 water. Okay, kind of thing there. So that'd be something else to kind of look at. Okay, I put this one in here. This is a golf course back in Nebraska that I'd worked with. The reason I put this one in here is because he was irrigating his greens using a block system very similarly that we use out on our baseball fields and on our athletic fields. And so with this one, he had a 9-hole course. and he was putting new heads around all of the greens because they were giving him some problems, and he was having troubles with irrigation, dry spots, costs, water costs, pumping costs. And so he went from these old original Toro 2001s, they were pretty old heads that he had there. He went ahead and then swapped them out with these Toro DT34s, where you can kind of see they're very similar to a Hunter I-40 ON, or with the ones with the opposable nozzles. And so by swapping out the sprinklers around the greens, he was able to reduce his run time from 20 minutes per application down to 14 minutes per application. And now he's actually continued to kind of go in there and just kind of fine tune the different nozzles that he has in there to kind of help improve things with this, what he was doing with this. And so in this situation, he was able to actually drop his run times significantly. And so he was able to kind of just improve his irrigation efficiency with this. And now he was just much happier with these sprinklers. I can kind of see had some dry areas that he's been kind of working on to get these things better. And for him, in this particular situation, by just improving sprinklers, he was able to, for 10 greens, which is about 2 acres or similar to a field that we would have like a football field, he was able then to save about 3 million gallons in a growing season, which made a huge difference for him. So changing the heads cost him about $70 per head, which run him about $4,800. But then he was also able to save $3,000 on well electricity in that 1 year. So he almost recouped the cost of the sprinkler heads by just the amount of water that he saved on running his well. Okay. So often another thing that he also does, this is something I don't know if you might want to kind of consider, is that he mows first. He mows first in the day. And then after that, then he does a quick syringe cycle with the sprinklers to seal off the grass, to kind of give them a chance to cool and kind of work in there a little bit. So something that he's able to do. His irrigation window used to be 12 hours, and now he's dropped that down to 6 or 7 hours, which has been a huge change for him in this situation. So with bigger facilities, having that kind of a irrigation window drop can be very, very helpful. Okay. So it'd be very similar then to switching from sprinklers like this to maybe sprinklers like this. And maybe it may actually give you an opportunity to improve irrigation efficiency and saving water this way. Okay, so this could be the upgraded heads that you might be looking at here. Okay. All right, pressure regulators. I don't know if you, in some of your sprinklers, you may want to consider, especially like in the landscape areas, am I using non-pressure regulated heads, like maybe some of the less expensive ones that we get at Depot or Lowe's, or actually ordering some of the more, the better heads out there that are pressure regulated? And as you can see with these, pressure regulated heads keep that pressure at the same, like let's say 40 PSI, and so your droplet size is going to be very, very consistent. If our water source is at a 70 or an 80 PSI, non-pressure regulated heads are going to give you more fogging, and you're going to have less efficient irrigation applications. If you can do something like this where you have larger droplets, you're going to be able to save water by doing that. Okay. And so this just kind of runs through there where you can actually make some improvements. If they're non-regulated versus regulated, you can kind of see there's going to be some differences in the amount of water that you apply, is what we're looking at there for some of the, especially a lot of the smaller heads. Okay. All right. So, and again, over time, if they're regulated to this and you've got 5 zones and you're watering number of times a day or every day or whatever your irrigation schedule is, you can save, let's say, maybe 50,000 gallons. And you can put that on your spreadsheet saying, you know what, I saved 100,000 here, 50,000 here, 20,000 here. And throughout the season, all of that water then eventually kind of adds up. Okay. All right. So pressure regulated sprinklers and check valves. So let's say we're using check valves and pressure regulated heads. Then all of a sudden we're saving 50,000 gallons on regulated heads. The check valves, we're saving another 12,000 or more, and with a total savings of 65,000 gallons and a $300 to $400 savings. That's just the $4 per gallon versus $6 kind of thing. So there's a lot of different things you can do with this, and it's a matter of just making little changes and keeping record of it. Okay, pressure regulated valves. If you have high pressure water sources, or if you're fairly close to a water tower, maybe it might be a good idea, instead of doing it onto the heads, maybe you can then just add a pressure regulator. This is that piece right here, and this one adjusts pressure for the heads. And this might be another thing that you could do then, is just regulating pressure from the valve instead of the receiving end of your sprinkler heads. Okay, and that's kind of what this example is over here with your rotors. In this case here, you might be able to save another 15,000 gallons by just doing something like that, depending on how your system is put together. Okay, another one that I wanted to also check then is I went to some various parks and various athletics facilities, and I found drinking fountains just kind of seeping or leaking, so to speak, here. And so I needed to so I got a graduated cylinder and found a way to kind of actually measure how much water was seeping out of these different kinds of drinking fountains, for a given period of time. And as I was running through this, and it was about 10 mils per second, which is about 1 gallon per minute, kind of a thing. And so it's like, how many gallons is that? Times a gallon, times 60 seconds, times 60 minutes, ran the whole thing where it ended up being about, just by this thing seeping out like this all day and not shutting off, you were running about 228 gallons of water per day, which is about 6,800 gallons per month, which ends up, if you have let's see, a 270-day growing season, or the seasons when these things are open and running, then it was about a 60,000 gallon water loss there. So just by getting one of these repaired, or having whoever it is that comes in facilities, or if you are in charge of those, that would be something else that you could actually then have repaired and take credit for the water savings on something like that. Okay. So again, over here, or in the bathrooms, sinks. This one here, this is one of those where we kind of had, you either bumped it with your leg, or it was an automatic one. This one would not shut off. And it was a matter of then, okay, well, I'm going to see how much water runs out of one of these without shutting off like that. And so with this one here, this one was about 1,100 gallons per day, or 34,000 gallons a month, or 300,000 gallons for a 270-day growing season. And so all of a sudden, this one, that's a pretty significant run of water right here, just by having this particular part of one of the sinks not shutting off. So all of these different kinds of things can make a difference. And like this one here was fairly significant. Okay. Urinals and toilets. Of course, I had to get in there and try. Let's see. So if this one wasn't shutting off, or this toilet wasn't shutting off, I wanted to find out, okay, how much water can we do with one of these? Well, estimated leaks on urinals and toilets then was about 14,000 to 20,000 gallons per month. Or if we had that 270-day season where they're open, you're looking at about 126,000 gallons per season on these. So a leaky toilet, a leaky urinal, all of these then can also kind of make a difference for us when we're kind of concerned about something like that. Okay. All right. So moving on. So again, these are things that we can check. Seeping or leaking quick couplers. And if you have these, we've always struggled with these where we just can't quite get that spring or the ring in there to kind of seal off, and you've got water sitting there and it's kind of just seeping out a little bit. These were fairly similar to a toilet. So again, you're looking at about 16,000 gallons a month for one leaky quick coupler, kind of a thing like that. So this would be another thing that you could actually then, if you fixed it and you stopped the leak, you could at least then say, you know what, I stopped this thing leaking. This is how long I feel it was leaking. And you can kind of then document, this is how much water I saved on that. Okay. This one here, depending on how you do your lip work, if you've got baseball fields, do you use water to work on lips over here? Do you use, or do you use brooms, compressed air, rakes, a whole bunch of different things. There might be different things like this. With this one here, one of the field managers that I was working with, they use water to kind of finish off or clean off those lips. And after about 60 minutes, that's at 30 gallons per minute, they were using up about 1,800 gallons just by cleaning up lips. So maybe just finding a way, if there's an alternative to using water to cleaning your lips, then you could actually then again document it, kind of a thing, which makes a difference. Okay. And there might be other ways that all of you clean your lips these days. Also, it may be a matter of going in later on with a sod cutter and kind of cleaning those with the sod cutter up as well, kind of thing. Okay. So recommendations from the industry. There's a whole bunch of different things, kind of like what we looked at before, marking them on glass as an as-built. And this is one of the things, again, here's that field here. And what you could do with something like this, if you have this laminated and in the crew room on a table or a break room table or something like this, the nice thing about it is then what you can do with a table-sized version of this, whoever's working out there can then spot something. And if it's just a single field, it may not be quite as critical, but if you've got a larger, like a 4-field facility or any other larger facilities, you might, if you're mowing the grass that day, you can kind of then say, you know what, I got a hot spot here, I got a hot spot here, or something else. I've got some weeds going on here, or I've got wet spots in these spots here, or I've got leaks going down over here in the valve manifold down in this area here, or I've got something going on the dish, around the dish over here by home plate, that you can also then, in this case here, mark those on there. So this way, whoever's working that day, whether it's you or part of your crew, whoever it is, everybody can kind of see what's going on and see, okay, this is what we need to work on today. And it may be something without having to think about it. It's like, oh, I forgot to tell them about this. And so oftentimes tracking problems, this might be one way to kind of do that. And it works. It's actually kind of fun that way for us in other situations. So collecting rainwater. If you've got some areas out there, it might be a matter of just finding some way to do that, or just having some 50-gallon drums or something like that. You can actually collect some of this water and use it for watering something, whatever it might be. An 80-foot by 20-foot roof, 1,600 square foot roof, will shed 1,000 gallons of water during a 1-inch rain event. So just we're talking 80 by 60, or 80 by 20. And so, that might be another way to find some way to harvest water that could be used for whatever it might be. Maybe use it for, the little spray bottles or whatever that we use when we're doing post game, working around the home plate or on the pitcher's mound or whatever it is, or whatever you might be using that water for. But then you could actually then document, you know what, we're doing this. We got this much rain this summer, and this is the size of the roof. And so you can actually document, this is how much water we collected and used for something else. You can document that and utilize that. Okay. And so this is a little bit more fancy, where theirs is actually then automatically returned into this sump here, and they're actually able to use this. They've got a storage bunk underneath this where they can actually then pump this water out. So that's a pretty significant one. But you could just use 50-gallon drums or whatever it might be to be able to kind of just collect some of that water in a short period of time and use it. Okay. So again, other recommendations from the industry: conduct full-time head checking and repairs. If you don't do that very often, and sometimes for us, we go out there, we kind of stick our heads once we fire up the sprinklers, and we can kind of see that. Or sometimes it may be a matter of just taking that little extra time. I don't know how many of you have said, you know what, we've got a lot of heads we need to raise up. They're just getting a little bit low, and it just might be a matter of some of those days. It may just be a matter of what can we do to just at least do a few at a time, just to get those heads raised back up. Especially if they're close to the warning track and they're covered with track material and everything else like that, can be a real challenge. So those are some of the things you can kind of do with that. But don't let the equipment dictate watering. Use whatever you have to make good watering decisions. All of these things can make a huge difference. Okay, out there. So, or develop a water budget. Learn your ET rates for your particular area. If you used 0.75 inches that week from ET, then maybe you can dial back your sprinkler systems. Find some way to reduce our turf footprint. For an athletic field, isn't going to happen unless we're going to do that out around the clubhouse or around the buildings and things like that. But our fields, we can't really do much with that. We could try root zone amendments, and there was some that I was at the trade show, and there's a few products there that I'd like to try out that may actually be able to help with water management. Might be something that we could consider with that one there. This one over here, this is where we have that opportunity to micromanage weaker areas. So instead of blanket irrigation, really find those others, and maybe we use that 1,000 gallons that we harvested, and if we've got some dry areas, find a way to be able to just kind of water some of those smaller areas using that 1,000 gallons that we could actually use for that, instead of firing up the whole system, something like that. So again, using moisture sensors, learning your system's history, soils, construction. If you're new to that facility, it becomes very, very important to know your inventory. What kind of sprinklers do I have? What fittings do I have? What parts do I have? What kind of controllers do I have? What's the history for everything else like that? That would make a big difference there. So, any experience? So one of the questions from Ben was, any experience with ultrasonic flow meters to monitor weeps, seeps, and leaks? These can be very, very good. Actually, that's something I hadn't mentioned, but I'm glad you did. Flow meters like that can be very, very helpful. And then TDR probe and clocks with moisture sensors have changed how the irrigation was scheduled. So all of these things make a huge difference. Ultrasonic flow meters can be very, very helpful to find those those leaks like that, or just a seep. And I'm glad you mentioned that, Ben. That was something that we had troubles with for years out at Medler Field here in State College. Is there was, for some reason, we were seeing that there were higher water bills, and then all of a sudden we had a huge jump in water bills. And it was something that they would, even since the facility was opened up, they had this issue and they couldn't quite figure it out. So we finally figured out through the system, because we didn't know our system as well as we should have. It had a master valve in addition to everything else with all of the rest of the manifolds. And that master valve from installation had a rock in it about the size of my thumb that was holding that valve open, so it was constantly running. So if there was any breaks or anything that was going on out there, we were getting constant running. And in that sand-based root zone, it was just kind of dumping under there, and we really had no way to track it. And if we would have had a ultrasonic flow meter or something like that, it would have been incredibly helpful for us, and we would have saved a lot of water and a lot of money and a lot of heartache trying to figure out what on earth was going on with that. So I'm a big fan of those. Or even if you've got an old water irrigation system, and you've got the old analog water meters instead of the digital water meters, if you've got an old analog one, those are also beautiful because they've got the little spinner on there, and that little spinner will also tell you that you've got some kind of water movement on there. The newer water meters are all digital, you can't see it, but with those, they usually had a little spinner on there, and they would actually spin and let you know that you had a water leak or a seep. So great question, great suggestion. I'm glad you mentioned that one because that's huge. And so for us, and I should have had pictures on that one of the rock that we pulled out of that master valve. And so again, those are important things then to be able to make sure that we're kind of up with when we're doing some of those things. So that kind of ends it for me, I guess. So that was kind of one of the questions from you, and I'm seeing where we are with time. We're just about out, but I kind of wanted to find out from you, what are some of the things that you've had luck with, or things that you had questions about, or anything else like that? What are some of the things that you had good luck with, whether with your irrigation system or water management, or some of just your basic decision making? Are there any things there that you have that we could kind of discuss? I'm kind of open for that. That'd be great. Are there anything else? But I'm again, Ben, I'm glad you mentioned the flow meters. They're great. Whether they're the ultrasonic ones or even the paddle ones, anything that you can do to kind of help you find out what's going on with that can make a huge difference. TDR probes, again, they rock. They can be very, very helpful. And oftentimes, instead of putting out catch cans, for irrigation audits, oftentimes we may just use a TDR probe and find out what was it before and what was it after. What was your soil moisture like before and after? And you could take some quick readings and just kind of work your way across the field fairly quickly. Or if you had both, it'd be really kind of interesting is to take your catch cans, find out what your volume is in the catch cans, and then also then take a measure with your TDR probes and find out, how do they translate together? Well, I'm putting down a half an inch of water. What am I seeing? What's the difference that I see in the field using the TDR probes? And, kind of a thing. And you could probably do it like immediately, and then maybe go back in an hour later and find out what's the difference, how much is moving out of your root zone, or kind of moving around that way too. So great one. I'm glad you mentioned that one. It was good. Any others? Anything else from you guys? Okay. All right. Well, hopefully you got my email address, brj8@psu.edu. So if you have any questions, either contact Jennifer or contact me. I'll be happy to answer whatever kind of questions or suggestions or comments that you might have about this. So
Thank
great.
you, Brad. That was a great presentation. And thank you to our attendees that were able to join us today. A recording of this session will be available on our website under our conference education page, and it will also be available in our education library. Thanks again, Brad, for a very valuable presentation. And I hope everybody has a great rest of their day.
Thank you. Thank you, everybody. Appreciate it.